All right, we're going to go over structures and pointers tonight, and next week we'll be in session in class. Week following spring break. Come back. Let me make sure. So yeah, this is this week. Next week, week off right here, 28 and 9 for spring break. Come back online that first week back from spring break. The next 2 weeks after that, face-to-face, and then online with the dice game, and then beginning work on final lap in week 13, 14, 15, and then final presentation in here on the 6th. So tonight we're going to be covering pointers and structures. Before we do that, I sent everybody an email or updated on the announcements, some events we have coming up. Some of you are aware of them, but some of you might not be. And I can always use volunteers. And since you're coding students, it might be something you might want to do. You're not required to, but if you want to, you can definitely do it. The first one I want to talk about, if you click on this here link, it'll send you to an events page that has the upcoming events, monthly, some weekly. The monthly ones are the Hour of Code that we meet at the mall from 6:30 to 7:30. It's 1 hour for drag and drop coding. Basically, we do some JavaScript. It's ages 5 and up. And I bring iPads to the mall, and then there's about usually anywhere from 15 to 30 people show up. The whole family show up with their kids and high schoolers, college, just a whole mixture, grandmas and grandpas. So it's kind of fun. It's just an hour out of your time. If you want to do it, let me know. I'll send you each an invite and also what we're going to be doing. That way you can kind of do it before you go and know exactly what we're going to be playing with. I'll show you some of the coding type of interfaces like this one here. I did for Ebates and Beloit. They create their own basketball game, mix and match sports. And then they can choose their team first, make a basketball game or a cross sport. So they do NBA, WNBA. And then they come in here, and this is called Blockly. If you've not seen that, that's what it looks like. It's a little bit like, well, it's called Blockly. It started out probably, you might have seen it with Scratch years ago with MIT. It's kind of advanced a little bit. But little instructions tell them what to do. It says attach a block to the one left arrow block and press run. Move the hand using the left arrow to reach the finished target. And so again, it's supposed to left arrow, attach a block to the one left arrow and press 1. And it's supposed to be a left arrow. And then continue on, so on and so forth, till you're all done. At the last level, they generally get to do anything you want to. It brings in all the stuff they've learned up through that 8th, 7th puzzle, and they can bring in a whole bunch of other stuff. And then once they're finished, what's cool about it is, and they run it, they're able to share it via text message or social media to their friends, and then they can play it and remix it themselves when they get it. So it's pretty cool. It's a lot of fun, and like I said, they don't have to have any programming language knowledge or anything. It teaches the thinking behind this, kind of like solo learn a little bit. It teaches logic before coding, if that makes sense. Logic before language. And so for years, we've always taught language first, then logic second. This kind of flips it, which MIT realized years ago that's kind of how people learn easier, is by understanding logic first, then give them the tools to keep that logic held up, if that makes sense. So anyway, that's an example. And it's RBC Hour of Code and they get a certificate of completion. And here's some photos of some folks that have finished. This is at Cherryville Mall, actually. And so this is an RBC employee that volunteers every month. She has for, I don't know, the last 7 or 8 of them. We usually have 3 or 4 employees, a couple of students. So again, you're more than welcome to come and help out. And it's over by Charming Charlie's on the 2nd floor. And I think this is my largest group I had. I had like 27 or something like that. So yeah, It's a lot of fun, and an hour, no brainer. Any questions on that? Again, if you want to volunteer, just let me know and I'll hook you up. You can do one or more or all of them if you want to. They're all booked till the end of the year, and it's once a month, the first Tuesday of the month. The next one is the Girls Who Code is weekly, and even though it says Girls Who Code, we have guy volunteers help, and then also boy. There is a boy in there this semester, one of the girls' brothers, so it's not exclusive to girls. But anyway, this semester, this is the third semester we've done it, and it's grades 5 through 12. And before the first two semesters, we focused on HTML, CSS, JavaScript, and basically they had a theme they chose, a community theme. Like last semester, it was volunteerism. So they created a mobile app, an iOS and Android, and created a website. The girls did. This semester, we're focusing on drones, coding with drones, coding with robotics, and coding with Internet of Things. We started out with drones, and I'll show you some of the stuff we've done. No sound, but you can see it. So that's the code. It's called Drone Blockly that can control DJI drones, and it can also control. This is a DJI Telo drone right here. And so they put in the code. It's about 15 lines of code to control the drone to go up. It'll do a flip here in a second, and then do another flip. That's right here in the foyer where we go every Wednesday. And then it'll do a 360, and then I believe it hovers for 5 seconds and then lands. The code language we're using is Blockly, Swift for iOS, and it'll also be controlled by JavaScript as well. So this was their second week. They did this the second week, and they're controlling the drone with an iPad, and it connects to Wi-Fi. There's no GPS enabled, but it's perfect. It's a perfect machine to learn drone technology, but at the same time learn coding. So it's kind of the best of both worlds. This next week, which is this Wednesday, we're touching on variables, and we're talking about how variables, static variables, in the case of drone technology, length, like a variable called foot, 12 inches is what we're playing with, and loops, we'll be playing with that. So instead of doing something like this, fly forward, yaw right, fly forward, yaw left, yaw right again, fly forward, yaw right, 180, whole bunch of those iterations to this here. And what's cool about this app is it's not integrated yet, but they do have a feature where you can view it. You can view the JavaScript of this right now. They're going to make the next iteration of it to where you can actually code it in JavaScript, which I think is kind of cool. And so, but you set a variable here, one called distance, one called 1 foot, and then they loop it 5 times. Distance increments 1 foot each loop. And then within that loop is a nested repeat that'll go forward, how many iterations it is. It'll be 1 foot, then 2 foot, so on and so forth. And then it'll turn as it's learning. When it finally gets done, it'll land. And then there's a video usually I put together exactly from start to finish. The devices aren't that expensive, by the way. If you're interested in drones, I know a few of you are. The Telo drone, I believe, is like $120, and it's a DJI, so it's a good product, but it's a low end. And it's mainly, you can fly it outdoors, but with the wind we have here, wouldn't recommend it. It's best to do indoors. So anyway, that's the second volunteer opportunity. We're doing drones, and then after drones, I think we're going into Ozobot, and I'll show you that one. That one looks like. This is a curriculum we use right now. In fact, I got a grant last year for $30,000 to implement this year to give to 600 kids, at-risk kids, starting in March. We're meeting with 15 local parishioners to train the trainer, basically. And then they'll bring kids from their church. And then from that, we'll bring in middle school teachers, train them. And basically, they'll take the Ozobots once they've went through a training session. We're going to meet in this room to do the training. They'll take 10 or 15 Ozobots back with them to their school or to their church. They'll do the training, and they can keep the Ozobots and do perpetual training with them, which is what we're going to recommend. Or they can give them away and then, you know, repurchase them each time, however they want to do it. And so that first 600, though, ran in for starting in October, and it was accepted in December, which I was pretty excited about that. Grant, you don't really know if they'll be accepted or not. Anyway, I put together a curriculum. We don't have any dates yet, but I'll need help for this as well, I know. But the curriculum basically is all done. I've got it all finished from beginning to end. Everything from a welcome video to checking in to computer science stats. These are kind of interesting. You might already know already, coming those of you right out of high school or fairly soon out of high school. Some of the computer science stats when it comes to K through 12. I'll go over a few of these. It's kind of interesting. 90% of parents want their child to study computer science, but only 35% of high schools teach computer science. If I was given raise a hand. In fact, how many of your high schools taught computer science or coding from middle school all the way through 12th grade, every level? They taught coding. Probably not one, right? That's pretty common. Should they? Probably should offer it for sure, definitely, like an elective or something. We're really pushing, though, for legislation to make it standardized, because that's the only way you'll be able to do it is do it standardized. If you don't do it standardized, it's never offered. Because it teaches logic, so irregardless if they're going to coding or not, it's going to help them in their future, whatever they might go into. Because it gives, you know, students enjoy, D1 students enjoy computer science, the art, and the arts the most. Notice here, only 54% of schools offer, even when students want them. You know, our students should learn to code. Our students should teach computer science. It's not learn to code. Computer science is different. Computer science is just about about learning technology. No, it's about logic, programming, solving, and creativity. It goes through whole lessons of stuff. But one of the cool things, the stats in Illinois, which is interesting. This is Illinois here. 58% of all new jobs of STEM are in computing. This is a year-old stat. I think at the end of last year, of December, 67% of new jobs in Illinois are STEM related. And we're only offering 1 in every 6 schools offer, K through 12 offer coding. That's crazy. So it means most kids aren't exposed to programming until college. First time they're exposed to it. Or they're self-taught, like most of you are. You taught yourself in high school. Kind of dabble around a little bit, right? That's how I learned whenever I first started coding. Then he talks about ways they can improve, getting involved by legislation, going to the schools, yada, 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 doing the hour of code, things like that. And then we go into things like, if you've never seen this, this is what the Ozobot looks like. And it's a little 1 cubic inch robot. And go through calibration, go through first is it follows lines of code. Show you this. This is a kind of cool video. We don't need a sound, but you'll see it. And depending on what it falls on, the lines here, the color lines, the solid lines, it just changes the LED color. But there's code lines that if there's like a blue, black, and let's say there's a blue, green, and red, it'll do a certain sequence of commands. that are predefined. But you can take it from the line drawing to what's called Ozobot, which you can actually control the robot to do things outside of lines. It'll basically just, you can code it to do whatever you want to do. And that's called the Ozobot, which looks like this. Once you code it here, what's cool about this is, I'll go this one full screen because it's easier to see it. This one's kind of cool. I call it code magic. Basically, you'll see why in a second. They code the blocks right to have the robot do whatever. Then once they get through coding it, and they have all the way up to advanced level. Advanced level goes into classes, iterations, pointers, and all that. It gets to a point here, it'll show you where basically you take the robot and put it on the monitor, and the light nodes from the monitor pushes through the robot's nodes to push the code into the robot. And then you double tap the power button and it does whatever commands you put in that program. And then they can share those commands, they can share those programs to one another. It won a lot of awards in 2016 is when it came out. There's a new version called the Ozobot Bit that has GPS and more proximity sensors, which I don't like those because it's kind of like an RC device really then. So that's what you put it on the screen. It pushes the flashes of light. You'll see in a second, it'll turn green, and it's pushing the code that they programmed to the Ozobot. Takes about 30 seconds to a minute. Loads a program. And it blinks green, it's pushing the code correctly. If it doesn't blink green, it's not. And the screen has to be full brightness. Kind of hard on the monitor because you're kind of holding it like this, but you can put it on an iPad and do the same thing. And then this is a cool feature. You can double tap the power button, and everything they coded in there, regardless if it's 2 lines to 100 lines, it's going to take that command and move the robot. And at the end, do like a little dance. So anyway, that's Ozobot, which a lot of people have never heard of it, and that's one of the ones we'll be doing starting in March with that $30,000 grant. Questions on that? Learn coding with robots. And then we also want to go over, we do have a job posting in programming, still open, in-house. It's a, pull it up here, programmer analyst, and there's the pay range. They're looking for a student. They could be near graduation if you want to be. You don't have to be graduated yet. Just have to have coding skills. It's looking for, and they'll teach you some of these things. Just tells you you're supporting Illusion is what our solution is on campus for online services. That's called Illusion. It's a company. They teach you that, how to support the MS Access, web app development, SQL development, database. And that's about it. Everything else they pretty much will teach you hands-on. You need some coding skills, which will be Visual Basic, C#, C++. They have in here Cold Fusion, but that's not really a big one. We still have apps built, by the way, in Cold Fusion for years. That's all we had on campus was Cold Fusion. A lot of companies still do use Cold Fusion, by the way. It's just a web development language. Actually, server web development language. Anybody heard of Cold Fusion before or played with it before? It's an older technology, but it still works. Still use it. And a lot of these stuff, like I said, if you've taken all the programming classes you can on campus and you're fairly skilled in programming, you know a little bit about, you've done some projects, I'd apply for it if I was you. And I've got 3 of my students that are programmers and on campus here. Both of them applied the last semester. They were students and got the job. So, and they took, the VB, the C#, C++, just like you guys have done, JavaScript, whatever, PHP. Questions on that? Cool. And this, again, I thought it'd be filled by now, but it's still not filled yet. So if you're not interested or you know somebody that needs a job that's a programmer, let them know. If you are interested, let me know, and I'll give you a good reference for the position. The next one I want to go over is in May, which is creeping up pretty quick, is the Internet of Things course. March, let's see who that was. Priority registrations right after break. Let me see here. Gonna be here before we know it, probably. Usually goes pretty quick after spring break. Let's see, important dates, records registration. Okay, so let's see. Oh, March 26th, Tuesday, 9 p.m. I believe if you have 30 or more hours, you can do priority registration. Opens at 9 p.m. I would get there first come, first serve. If you've ever done priority registration, the server usually dies within the first hour. So first come, I mean, get there right at 9 p.m. That way you get your courses registered. Otherwise, you have to wait till next day, which kind of defeats the priority registration part, but that's a whole other thing. That's for summer 1, and then also summer 2 as well. The course I'm going to be talking about is summer 1 only. Has anybody ever taken a summer 1 course before? Oh, yeah, you have, I know. Yeah, okay. So it's basically 4 weeks. It's a pretty cool deal. It's right after our spring semester. We'll be meeting in here for 4 Saturdays from 7:30 to 8. It'll be check-in time, kind of chill out, get some handouts, and we'll be doing 1 project a week on Internet of Things from 8 o'clock to like 11:30. And then from 11:30 to noon, we'll be just kind of playing with them and showing each other what we did. The first project we'll be playing with is motion detection. And when it'll look just like this, basically an Arduino motion sensor and a particle photon device there on the right. We'll create that. And when it senses motion, it'll send you a message, an email message. Control servo. This one is called What Should I Wear? And it controls an actuator arm, a robotic actuator arm. That's a shadow box, a picture shadow box like you get at Michael's. Behind it says, what should I wear outside? And it has different things that you should wear. It checks the weather every 15 minutes, and it moves the actuator arm to whatever it should be pointed to. The battery we'll be using on the second one will be a 3-month lithium battery that'll be rechargeable. That you just hang it on the wall and it just runs for 3 months. There's ways you can tweak it to make it run longer. If you only check for the weather every, say, 30 minutes, it's going to last longer. Or every hour, it'll last even longer. So we'll talk about that. And then wearables. Anybody have a smartwatch or any smart device that you wear or you use to work out or walk or whatever? Okay, everybody, or a smart car. You can check your tires now, your gas, all that stuff. Start your car remotely, and then we'll do that for a while. But anyway, we'll talk about wearables, which is a $59 million, or not $59 billion this year alone will be spent in wearables. 129 trillion in the next 5 years will be spent in R&D for wearables. So it's going to be a huge market. It already is a huge market, but there's going to be and already is a dearth in skilled people that know how to program in Internet of Things devices. So hopefully this will kind of help those who want to maybe go into it on your own or get hired at a job somewhere. This one's actually going to be that circular device on the left is a sensor. These are all Arduino sensors, by the way, we'll be using. And then it's going to be connected to, as it sees in the picture there, a particle.io. It's a website that creates these photon devices that are Wi-Fi enabled, or you can get one for cellular. We'll be using Wi-Fi ones. And once it's set up, again, you can set it up to set alerts. In this case, it's just remoting in and changing the color of the circle to whatever you want it to be. It can be put on clothing, on shoes, whatever. It can be connected to a device to maybe do heart rate, breathing, stuff like that. We'll talk about that. And then the third Saturday or the fourth Saturday is temperature reading, Arduino sensor. And you'll be doing, and most of these weeks you'll be doing coding a lot with Python mainly, and then some JavaScript. But this basically is just a Python script. It shows what the temperature is, publishes it. It does a 30,000 millisecond delay, and then publishes again the humidity, and then tweets that out. You can tweet it out, or you can put it in an email or text message or whatever. So what's cool about Particle.io is the company gives developers 250 projects at no cost where you can host your apps. So that first Saturday, you'll be creating your account, getting all your parts for the 4 weeks, which, by the way, I'm working on getting a grant for all that, so we don't have to pay a dime for that. It's not real expensive, by the way. Each project only costs about 35, 40 bucks in parts. It's like dirt cheap. Like the particle sensor for the Wi-Fi, $19.99. It's really inexpensive. Most of the sensors for Arduino, anywhere from $5 to $8, $9. So really inexpensive. So 4 Saturdays, 4 everything projects. Again, let's see, the date was March 26th at 9 p.m. And this one we are promoting outside of campus. So the reason I'm telling you to do the priority, we have to fill this room. Once it's full to capacity, which is 20, we're cutting it off. And so I'm guessing this will fill pretty quick. So whatever slots we don't have open the next day or whenever it opens to the general public, that'll definitely fill up pretty quick. So I want you guys to know about it early. That way you can register if you want to do it, if you're interested in all the Internet of Things, or if you just want it for a hobby purpose or, career in the future. Cool? Questions on that? All right. That's that one. Now let's get into this week. First, we're going to be going over some notes and then some examples as always, and then your take home. So solo learn this week, we've got inheritance and polymorphism. You're reading chapters 14 and 12. Before I forget, let me copy that link. Oh, has anybody seen Minding the Gap, by the way, that was on the Oscars or nominated? Anybody see the movie yet? Have you seen? I do recommend seeing it if you've not seen it. Well, RBC grad created that movie, and my wife and I saw it the month it was released, which was about a year ago. Definitely recommend it. Great. Didn't win, but it was just a big thing to be there, I think. Pretty cool. And so if you've not seen it, it is available on Hulu. It's also available on, if you have Roku at home, the Roku free channel. I noticed it's on there as well. It was highlighted on that last night. So it's a good movie. Good documentary. Not movie, a documentary. And it is, if you're from Rockford, it's exactly what a lot of kids go through here in town, and they show, pretty gritty on what they show and what they go through and what their home life is like, and not always so nice. And I think it's pretty cool. Pretty cool that somebody from Rockford that was noted as that. He was interviewed. Somebody, I don't know, it was John Stewart, I think. I can't remember the guy's name. Anyways, one of the interviews I watched him on, they said, "What are you going to do next year?" He goes, "Well, the bar is set so high, I think I'm going to do nothing next year." So, but if you've never done, I've done very little video editing in my life, but the video editing I've done, it's a lot. It's very tight. It's a lot of work. A lot of work to do video, just the editing part of it. Forget the shooting part, which, yeah, that's a whole nother thing. But a lot of work involved in that for sure. So pretty cool. If you've not seen it, Hulu, and also the free Roku channel. Because we cut the cable on cable TV about 5 years ago. We only use Roku, and we've been using the last 2 years YouTube TV, I think it is. Yeah, YouTube TV for 40 bucks a month. That's pretty good. Anybody else use any other cut the cable stuff? That what do you use? Hulu. Okay. Anybody else use anything? Huh? Yeah. Oh, the other one too. US TV Now. That's a good one too. USTVNow.com. It was originally designed for military families and still is. They get it free overseas, but it's about 45, 50 bucks a month. It's not as many channels as YouTube TV, but they have different channels, and it's unlimited DVR on both platforms for the YouTube TV and also the US TV Now unlimited DVR. So that's kind of cool. All right, so pointers in C++, and we'll also be looking at some examples as well. Two examples. One you'll be modifying. The last example you'll be modifying tonight. But the first thing it talks about on this slide is a pointer is a variable that holds in memory the address of another variable of the same type. And one of the differences between pointer right off top and get all through your head and in your brains is unlike any other, it's not like a variable because it's available throughout the entire app, a pointer is. And it's referenced and held once it's declared, it's held in memory one time in that declaration and never redeclared again. So it's very, pointers are very efficient way to use memory in your programs because they're not being, one of the ways memory leaks occur, one of the easiest way memory leaks occurs when you're redefining variables over and over again in your app, right? You can actually watch the memory increase on apps that do that. By using pointers, you less the likelihood of that occurring because, again, you're defining first that pointer in memory, and it locks it into that memory of that computer during the run of that app. The memory address is a location of another variable that's been stored in memory, and it supports dynamic memory allocation routines as well. So regardless what the device is irrelevant. So it could be ported to a game, it could be ported to a Windows app, it could be ported to a web module, doesn't really matter. It all works the same. And pointers are probably one of the least used variable types in programming in C++, and it should be more used in programs, and you'll see why tonight. So declaration and initialization of a pointer. Syntax, you have the data type, the variable name, also the address, which is the operator. It's a unary operator that returns the memory address of that operand, and here's the operand in the normal variable. And so you'll notice here in the example, int x equals 10, int pointer equals, and then the operator, ampersand, and x. This is a pointer to x. This here is defining x now as a memory location and contains the address where the variable x is stored in memory. And it'd be something like this is what the computer would see or to read out. Because you can print out either the address of the pointer or the value of the pointer, one of the two. Either one you can do. So in this case, x could be 10, is 10, but the pointer variable address of x is that OX number at that runtime, because it changes each time it runs. It's a hexadecimal number of the pointer reference in that memory. Free store is a pool of uncollected heap memory given to a program that's used to program for dynamic memory allocation during execution. Heap memory in Windows 32-bit was up to 2 gig limit. If you went over 2 gig limit in your app, it would crash, or still does crash, because you can only have 2 gig limit on an app in 32-bit. 64-bit doubles that. It's a 64 module, and so you go to 4 gig limit on a 64-bit application. That still doesn't mean, even though you get more memory in a 64-bit application, that we shouldn't use things like pointers and be more efficient in the app, because it's just going to eat more processing power if we don't. And pointers they can't be used in every instance, but in instances where they can be used, they should be used. So dereferencing a pointer operator in a unary operator that returns the value is stored at the address pointed to the pointer. Here's the operand in a pointer variable. So example, int x equals 10, int, and then you have the asterisk pointer equals x, ampersand x. X is going to be now the memory variable of not only 10, the int x, but also the memory location. So if we did a C out of PTR, we get the address stored at pointer will be displayed. If we did the asterisk or the star PTR, we get the value pointed to by the pointer will be displayed. Okay, so we get either that hexadecimal number or the variable itself. So pointer arithmetic, we'll be doing a little bit. We're changing around stuff, swapping numbers and stuff tonight, swapping strings. Two arithmetic operations, addition, subtraction, may be performed on pointers. When we add one to a pointer, we're actually adding to the size of the data type in bytes, and the pointer is pointed at. Example is that a pointer x, and then increment it by 1. The current address of x is, say, 1,000. Then x++ statement will increase x by 2. The size of the int data type will make it 1,002, not 1,001, every time it's iterated. So in arithmetic, as far as like a for loop or something, pretty similar as everything we've done thus far in variables. Pointer plus plus, or in parentheses, increments a pointer, dereferences unincremented address. This command first gives the value stored at the address containing the pointer, and then increments the address stored in the pointer. Then you have the decrement, increment pointer, and dereferencing. On the next one, this command increments the address for the pointer and displays the value at the incremented address. Then dereferencing the pointer on the third line increments the value pointed, it points to the example. And this command first gives the value stored at the address and containing the pointer, and then increments the value by 1. And then dereferencing pointer on the last one, post increment the value it points to. This command first gives the value stored in the address containing the pointer, and then it posts the increments of the value by 1. So when it comes to pointers and arrays, which is used a lot, and one of the examples we look at in a second does that. It treats the name of the array as a constant pointer, which contains the base address of that array, and then the first location within the array. So an example like int x10, x is a constant pointer, which contains the base address of the array x. You can also store the base address of the array in a pointer variable. It can be used to access elements of the array because the array is a continuous block of memory of the same memory location. Example, int x5 array, int pointer equals x. Pointer will contain the base address of x. We can also write int pointer equals ampersand x, and calling 0, which would be the first one, which would be 5, because there's only one in there, will contain the base address of x. This over here is referring to the actual memory location of x and pointing to that memory location. Once it's been defined in your code, and it's generally going to be predefined, initialized at the top end of your code, all of your pointer functions are generally going to be called and defined. You can change them after that, but what's nice about it is once they've been defined and initialized, they don't have to be initialized after that. The values can be changed, be swapped around, but that memory location is locked in just for that pointer. So some valid and invalid examples of pointer, like pointer plus plus, valid, x plus plus, invalid. This happens because x is a constant pointer, and the address stored in x in that cannot be changed. A pointer is not a constant pointer. Thus, the above statement will make pointer point to a second element of the array. Constant of the array x can be displayed in the following ways. As we normally have done here in the for int loop, incrementing in a C out of a pointer possibly, another for loop, incrementing a pointer, incrementing it, and then another pointer example here. But you'll notice each one of these for loops are using the normal integer pointers or integer loops to just display the pointer. So here's an example of character strings in a pointer. Consider the following program in a main. You've got char string str equals computer. We're going to be using this week the actual variable type string instead of str, by the way. But char str equals computer in quotes. The pointer is called is a char cp, puts it in that pointer, and then it uses in the cout just the variable name computer, and then the variable pointer variable would, and the cp would be pointed out would be the memory location. CP is the address of the str, and the statement cout would print out the computer as giving the address of the character of the cout, resulting in printing everything from the character to the first null character that it follows. So arrays of pointers, like any other array, we can also have arrays of pointers. Common use of an array of pointer is an array of pointer to strings. We'll be doing one of those tonight and for your take-home, as a challenge anyway for your take-home. So here we have an array of character pointers used for storing several strings in memory. So we have the name of the character called vehicle, and it's an array. And we have car, van, cycle, truck, bus. And doing a for loop of up to 5, because there's 5 in there, from 0 to 5. While I is less than 5, meaning it's going to go from 0, 1, 2, 3, 4. It's going to see out that array vehicle, which it should kick out car, then van, then cycle, then truck, then bus. So the example above, the vehicle 0 contains the base address of the string Sunday. Vehicle 1 contains the base address of Monday, so on and so forth. In this case, car, van, cycle, truck, bus. Constant pointers, it means that the address stored in the pointer is constant, and the address stored in it cannot be changed. It will always point to the same address, and the value stored at this address can be changed, though. The pointer to a constant means that the pointer is pointing to a constant. The address stored in the pointer can be changed, but the pointer will always point to the constant value. So you have a constant pointer or a pointer to a constant, either one. So here we have an example of case 1. In X is 10, Y is 20. We have P1 being an int pointer, and it's referencing in memory the X value and the non-constant pointer to the non-constant integer, and the memory location of X is also in that. And then pointer reference now is going to be changed to 20. If we try to do P1, val also pointing back to XY or the ampersand Y, address in P1 can be changed, now it'll be pointed to Y. Case 2, if we did a constant integer, first one was a constant pointer, now constant integer, X equals 10. We already know by that call right there, X can't be changed, it's a constant. Int Y equals 20, that can be changed, Y can. Constant int pointer P2, ampersand X, a non-constant pointer to a constant integer. The next line is invalid because the value cannot be changed. A P2, memory location is going to stay the same. P2 equals referencing Y, valid, the address store can be changed. And then pointer 2 equals 100, invalid, P2 is pointing to the constant integer. This was another example of both an integer constant and a variable constant in a pointer. So some of the syntaxes to remember when referencing variables in a name that acts as a alias or alternative for something that already exists. Data type variable name equals an already existing variable. Example will be int num equals 10. Int ampersand sum equals num. Sum is a reference variable or alias for num. And you did a little bit of that when you did the classes last week, where you could create a class, and then within a function, rename that class to something else. Same type of logic. Both num and sum will refer to the same memory location. Any changes made to sum will also be reflected in num. So let's look at some examples here. I'll switch to some examples. The first one is this pointer example, basic pointers. And I had to put in here and it does have, by the way, the string include statement. And I did put in here for replet's sake anyway, since we're using GNU CC, this program GCC diagnostics ignored write strings. This is ignore the annoying depreciated conversion from string to constant, blah, blah, whatever it says. So that's why that's brought in. So inside the main here, we're declaring an integer called x, declaring 10 as a value. Pointer, and remember this is ampersand x now is going to give a memory location, plug it into the pointer, memory location and the value for x, plug it now as part of the word pointer. So the first C out, in fact, I'll just run it so we can see it as it's ran. This way, a little bit bigger this way, there we go. So first, address stored at PTR will be displayed. C out PTR. So this is the address of PTR, the memory location of PTR. Now, if I was to stop this, started out with, or it ends with a 5058. Okay, memory location C out changed. It's F128 at the end now. So it's a memory location of that PTR. Next C out is the value pointed to by PTR will be displayed in the next one. And so this one, notice has the pointer in front of it. It's going to kick out 10 now, which is a value of x. This is the memory location of x pointer, the value of the pointer. The next is using variable name, put unary operator before the CP and run it again. And so here we have computer, and it's going to be plugged into a str. str is going to be put into a pointer. Then use a variable name unary. So this here, str, is going to be the memory location. Boom. And then next is a pointer variable, which is going to give the actual value of that memory location. Computer. Then next is showing an array of character pointers. So here we have an array of character pointers, array called vehicle, and it's a pointer, has in there car, van, cycle, truck, bus. A for loop, kicking out that and getting out the information, which is what? Car, van, cycle, truck, bus, right? Next example is this pointer example one. Now this one we're going to do some change of range over to this one a little bit. So this one we're going to do is before and after swapping, but we're going to do the first one. First one's done for us. So we have in here a function prototype of a called swap, and it has in here two references here to that pointer. One is both of them are ints, and it's going to store it in memory. And a second, we'll do a second one called swap2, but for right now, let's go over to the first one. So in the main, we've got integers A and B declared 1 and 2. Before swapping, A is 1, B is 2. Goes to the swap, bringing in that value and the memory location. And I have to do this because I'm on N1, we couldn't just do N1, N2, because if we did N1 here, N2 would change. If we did N2, I mean N2 here and N1 here, N1 would overwrite 2, so it wouldn't work. So int temp, temp's going to become N1, N2 is going to become N1, and then temp, which is N1, is going to become N2. Now, one of the differences between pointers, what we've done thus far with functions, is what do you notice is different between a function and a function that we've done thus far that returns a value and a pointer function? What's the difference? A major difference. Yeah, no referencing. There's no return value either. You notice there's no return value needed in this. So I did this on purpose. They're doing a void function. It's not going to return anything anyway. So it's referencing a variable prototype that was done up here at the top. These two variable prototypes both of these are pointers to a memory location and a type of data, both. So when it comes back, after swapping, A is now 2, B is now 1. So what we're going to do as a challenge here is I'm going to have you create on line 9, a prototype called swap2. Instead of being int, it's going to be string, and include the ampersand just like it has for the int. The function for swap is already created. Swap2, I believe. Yeah, it's already created. I left that in there. But then after you do that, in the main, follow the directions on line 24, 26, 28, 30, 32, 34, 35, 36, 40, 42, 43, 44. And it should basically look just like this. It'll be before swapping, after swapping, but it'll be before swapping, referring to your first name, last name, and after swapping, it's going to swap your first name and last name, basically. So first is going to become last is going to become first. Before swapping, first will be first, last will be last. After swapping, your first will become your last name, your last will become first name. Okay? And then I'll show you the example finished on the overhead after you're done. Give you a few moments to do that. If you just follow the logic in the int, you'll be fine. And you can even copy and paste the before swapping and after swapping logic and just replace it with the text you need for the first name, last name. Cool?
What's the login? Login.
What was it now?
What's the login?
What's the login? You can use your S number or CIS290 and then bootcamp for password. You're talking about for the Macs, right? Yeah, you can use your S number, but CIS290 and bootcamp's going to be faster. Just follow the logic in that example. Again, it's the only difference between swapping type data, string type data, everything else is pretty much exactly the same. Example. Duplicating what's done for swap. 2 will be duplicated what's in swap. Int. And also make sure on the variable declaration for string, the string comma string, make sure and don't put a space between the word string and the ampersand. That'll cause an issue. Spaces, an issue has to be shoved right up against that data type. Now, I don't think in Replit, you won't see the word string show up in the blue syntax, even though it'll work fine. I don't think blue string shows up as it shows up as black text instead of the blue, but it should be fine. And then you'll just call on line 9, you'll call the void swap2 instead of swap. If you have questions, let me know. I try to strip the code underneath the comments or below the comments, so hopefully it makes sense. You guys see a picture of the 100-car pileup in Wisconsin over the weekend? 115-car pileup. Yeah, crazy. Southwest Missouri had ice all the time, but we're not used to ice here, I don't think. You guys, we're not used to having ice in Illinois or Wisconsin. Maybe Wisconsin a little more, but I don't think so. Maybe about 3 or 4 more minutes, then we'll go over the solution line by line. And your solution could be different than mine. Being placed a little bit different than mine if you want. If it, no big deal, as long as the outcome's the same. The formatting might be a little different on yours. How are we doing? You guys need a couple more minutes? Okay. Need more time? No? All right. Let's go ahead and go over my example, my solution, which is also found right here as well. All right. So, show what I did on mine. I'll go ahead and run it. So, first name, last name, port swap. My first name is Chuck. My last name is Conkle. After swap, my first name is Conkle. My last name is Chuck. So here is the swap to string with the ampersand right after each string. Inside the main, declare string, first name, last name. I declared them empty initially. And then C out for entering first name. And then doing a get line C in first name. Then C out for the last name. Enter the last name. Also 200 first name. Before on line 27, I put a backslash n just to put a space in between the line above and enter first name. And then enter last name. C and get line for that. And then the before swapping, you gotta just copy and paste the stuff above. My first name is first name. My last name is last name. And then the swap command will send it the first name, last name, and do the same as the integer did. It'll take the first name, put it in a temp string, and replace that temp string will replace your last name, which will be now your first name, and first name. First name will become your last name. Last name will become your first name, which is N2, last name. Temp is first name. Comes back. See out after swapping. My first name is first name. My last name is last name. End. So something like that. If you have that, you're good. Questions on that? Cool. All right. Your take home is going to be this right here. All right. So you're going to have in this one a more on characters and strings as far as in C++. You'll do line 7 through 12 with getting in first name, last name. You can also use, by the way, in this one, if you want to, the string variable type versus a char variable type, if you wanted to. So what is the initial of the first name? First name. If you're going to do string, though, make sure to do a C and get line instead of just CN. You're going to do string type. And then what is the first name? First name. What is the initial of your last name? Last name. And then at more interesting output, my initials are first name, last name. What does your output look like? And then 2, we'll input some numbers, give an integer, and then tell what that integer is. And then change the from integer to float. Declare an X, float. Number is. And then final output is going to be something like this. What's your first name, last name, and then just hello first and last name. Challenge is going to basically create a pointer function, adding above to the input string 7 through 12, adding a pointer function prototype called void printout with void pointer strings. Create a pointer function named printout with 4 pointer strings and have in there concatenation strings that you just declared above. So of your first name, last name, and email, put them all together as a challenge. So an example would be first name Tom, last name Cruz, email tcruz@topgun.com. It'll concatenate it in the pointer function, put it all together, and it could end up looking something like this. All right, so 2 for the integer, first name. And that's the end of the assignment before the challenge. Just say hello, whatever you put in. So everybody should be able to do the challenge. And it's going to go to the pointer function that's going to take what you put in, print out prototype, and set it to a function that's going to concatenate it together. So again, that's the challenge. You don't have to do it, but you should be able to do it. It's not that too difficult. You want to change up functionality as far as formatting and other variables in there, you're more than welcome. Other prototypes, you can definitely do that as well. Questions on that? Cool. Done when you're finished, and I've been trying to finish up or hit complete on Monday on those, the following Monday. So I think I did all of last week's tonight. Review questions as always, get those done. And then that's it for week 7 besides the discussion. And looking ahead a little bit, next week we are face-to-face, and we'll be doing classes next week. And then after that, after break, we'll be doing more classes online. And then after that, more pointers in week 10. And then showing you in week 11, reading and writing files in Replit and C++, which is common occurrence for programming. Don't really get into database, but reading and writing files, we'll get into that. And then week 12, a dice game. You'll tweak it to your own liking on a dice game. You could even make it like a flip the coin game as well as a variation of it. And then week 13, 14, and 15, working on your final lap. If you need any help with the final lap and you're kind of already looking ahead a little bit on what you want to do and you need help with it, let me know. I'll be more glad to help you. Give you some code snippets or something, some resources to help you. Now's the time to kind of look at it and play with it a little bit to see where you're going to go with it. In the final lap weeks, I'll just kind of jump ahead to show you some resources in there for the final lap resources. So here are some examples of ones like guessing game, calculator, game tutorial. Here's the guessing game one. That's loading. I'll go on the other one here. I think this here is a list of apps, maybe. Yeah. These are lists of apps done in spring 2018 for the Coin Costs game. Has a pause function in it, timer function. Again, you can play with that one. A whole bunch of different ones you can look at. There is, when we get into the, towards the, when you're working on your site and your final lap, I'll give you more examples from spring 2018 of the programs that were created by the students for that class. Everything from gaming to a story, kind of like an Oregon Trail type thing where you choose different outcomes or different choices along. One of them did like a Scooby-Doo one, where basically chose the Scooby-Doo concept, and you could choose a Scooby-Doo storyline basically by depending on what you chose. So a whole bunch of iterations and loops and pointers in that one. So anyway, a lot of fun stuff on that. And that's in the final app resources is where all that's at. Well, I include that in each week's information starting in week, what is it, 13, 14, and 15. So, and then for 13, 14, and 15, attendance optional. For 13 and 14, I will be here those nights for help. And then 15, we'll get together just to check to make sure your checklist is good for your app. So say you get to that week and something's not quite working, well, you'll have to make a decision because you're limited on time at that point. Okay, we're going to have time to fix it. Or you might decide, no, I'm not going to have time to fix it, but I'm going to talk about it. Here's what I wanted to get done and I couldn't get it to work or whatever. You'll always have stuff like that because we'll talk about that during your presentation. Okay, questions? All right, well, good class tonight. We'll see everybody next week. If you have any questions about volunteering or want to help out in the drones or Hour of Code or the upcoming Ozobot stuff, all those are a lot of fun. And for those that volunteer, I generally give you the device to play with sometimes too, take home to get used to it, especially with the Ozobots. I have extra ones at home. I'll just give you one to play with. And I've been known if students do it enough, I just give you the Ozobot to keep it. Now the drones are a little bit more expensive. I can't give you one of those, but I've been known to give those loaners as well for the drones if you want to play with it. Don't mind doing that. And then when we get to the Girls Who Code, and we get into the Internet of Things, you will be playing with actual devices I'll be using in the May term, because what I'm doing this semester with the Girls Who Code is they're my test bed for the May class, basically. They're testing all the stuff you'll be doing in May with the Internet of Things devices. So they'll be working out all the bugs with that. So that'll be kind of cool to play with that. So if you have any questions or want to be a part of the volunteering of any of the things we're doing, let me know. And, if you can't do it because of work or you don't have time, don't worry about it. But if you have an hour a week or whatever, like the Hour Code's once a month, Girls Who Code is an hour a week, you know, it'd be beneficial to you to do it, to kind of just give of yourself, and you'll learn stuff as well. But it's cool to kind of help others as well. It kind of helps. It helps you as a person, I think, and so it'll help your resume as well. A lot of employers will look good upon you whenever you're volunteering your time during your college years, where a lot of students don't, and that kind of shows initiative on your end that you want to do more. So that's it for tonight. If you have any questions, come see me. Otherwise, see you next week. Stay warm. Yes, sir. How's it going?
It's going good.
Yeah.
Hey, this job, I'm